We had great time TensorFlow, but PyTorch is more flexible, much more intuitive, and way more fun to use. Welcome everybody to this first lecture of PyTorch 0 to Hero playlist, where we are going to learn about what is PyTorch, what are the core features of PyTorch, what are the modules that PyTorch provides us, PyTorch versus TensorFlow, and lastly, what are the libraries that are compatible with PyTorch, therefore creating an ecosystem. So we'll learn everything in this lecture. So take a pen and paper, grab a hot cup of coffee, and let's get started. Okay, so what's PyTorch? So simply you can think of it as a deep learning framework based on Python, using which you can build neural networks from scratch. So you can think of it as a toolbox which provides you all the tools for building neural networks, like artificial neural network which specialize in tabular data, like convolutional neural networks, recurrent neural networks, LSTMs, GRUs, and using it you can also build your own transformers and LLMs. So the idea is simple. You first build your neural network in PyTorch, and then you have your data set, so you get it from Kaggle or wherever, and then you train your neural network on this data set so that this neural network gets trained and it can generalize for new and unseen data. So that is what is the whole workflow of PyTorch, and PyTorch makes it very easy. And the reason why PyTorch is so much powerful is because it has very less abstraction, and also coding in it feels very manual, and you get a complete sense of control over your neural networks. And that is why it is used so much in research, because in research, like, you have to try multiple different things, so you don't want any abstraction involved, and that is what PyTorch provides us. And because PyTorch is based on Python, you can use all sorts of Python libraries with PyTorch. So you can use Matplotlib, Seaborn, NumPy, SkyPy, scikit-learn, everything. So you can use all this alongside with your PyTorch, because together they are all a part of Python environment, and that is what makes PyTorch so powerful. Next, PyTorch is open source and it has been developed by Meta. Now you can ask that why is its name PyTorch? Because it's a deep learning framework, but then you have the name as PyTorch, which has no link. So actually PyTorch is the combination of Python and Torch. So we all know what's Python. Simply, it's the OG of all programming languages, right? But what's Torch? So Torch is an old school deep learning framework which is based on Lua, and it is used for efficiently handling tensor operations. But the problem is that no one actually wanted to code in Lua, because as you all know, the whole machine learning and deep learning community, it was just focused on Python. So there was a problem, and boom, Meta found this problem and they solved this by inventing PyTorch for us. Okay, now it's time for a quick summary. So first, PyTorch is a Python-based deep learning framework which optimizes in tensors and handles tensor operations very efficiently. Next, using PyTorch, we can build all sorts of neural networks and train them from scratch on real-world datasets. Third, PyTorch involves very less abstraction, and that is why it is used extensively in research. Fourth, because PyTorch is based on Python, we can use all sorts of Python libraries alongside with PyTorch, like NumPy, SkyPy, Matplotlib, Seaborn, OpenCV, scikit-learn, like everything. Fifth, because PyTorch has been developed by Meta, it is very reliable and very powerful. Okay, so now let's talk about the core features of PyTorch, which makes it so much powerful. So first, everything in PyTorch starts with our tensors. So they are the fundamental unit of PyTorch, and without tensors, there would have been no PyTorch. So suppose you got your data, you can represent them in terms of tensors. you got your neural network parameters like weights and biases. You can again represent them in terms of tensors. So literally everything in PyTorch can be represented in terms of tensors. And that's why I'm saying that it's the fundamental unit of deep learning and also PyTorch. And guess what? PyTorch is highly optimized for efficiently doing all these tensor-based operations, and that's why it is so powerful. Next up, we got dynamic computation graph. So you can think of PyTorch as a note taker. So every time you perform any action or any operation, that operation it gets appended into that computation graph, and it makes debugging very easy. So let's say we have an equation ax plus b, and we have our a node, x node and b node. First we perform our a times x, and then with that a times x we add our b node, and that is what a whole computation graph looks like for the equation ax plus b. And then we got AutoGrad, the real MVP. So AutoGrad is this automatic differentiation engine inbuilt into PyTorch, which basically computes gradients for us. So if you know some deep learning, then you know that in backpropagation algorithm, we have to compute the gradients of our loss function with respect to all the parameters of our neural network. And AutoGrad makes this process easy by automatically computing all these gradients, so that we don't have to manually compute them and waste our time. So that makes the whole training process much more easier and much more efficient. Next up, GPU access. So PyTorch gives us the power to actually move our tensors into our GPU. So we can literally handle all these tensor operations on our GPU. So instead of training a deep neural network for suppose days or weeks, we can just use our GPU and train it for like few hours, because using GPU we're getting a 30 times speed up as compared to CPU, and that's the beauty of PyTorch. Next up, the NN module. So PyTorch gives us NN module using which we can build our neural networks much more faster and much more efficiently. How? So you can think of the NN module as the Lego set. So in Lego we have all these different blocks and we attach it and we build something bigger. Similarly, our NN module, it provides us pre-built things using which we build our neural networks much more efficiently. So it provides us linear layers which we use in ANNs, convolutional layers which we use in CNNs, RNN layers, LSTM layers, GRU layers. It gives us loss functions and activation functions so that we don't have to manually code them from scratch. And trust me guys, these are highly optimized. So instead of coding them, we can just use them and build our neural networks much more faster. Next up, the Optim module. So PyTorch provides us this Optim module, and you can think of it as a gym trainer whose task is to push you harder and help you in training better, right? So if you know some deep learning, then you know that in the backpropagation algorithm, we need to use the gradient descent to update all our parameters. And Optim provides us all optimization algorithms like AdaGrad, SGD, Adam, RMS prop, energy, momentum, and we use these algorithms to basically update our neural network parameters so that we don't have to manually code the gradient descent logic from scratch. So instead of coding our gradient descent logic, we just use these highly optimized algorithms and just save our time. Next up, the data utilities. So PyTorch provides us awesome data utilities like dataset and data loader, and we can use all this to efficiently handle data processing, batching, etc. And in the upcoming lectures, we are also going to see how to use all this, so don't worry. Okay, so now suppose you have built your PyTorch model, but what if you want to use it in some other environments other than Python? So is it possible? The answer is yes, and that is what Torch script actually helps us in doing. So it lets us run our PyTorch models on environments other than Python, and this is what ensures cross-environment compatibility, and that's why I said PyTorch is very reliable and powerful. Okay, now suppose you have built your deep neural network with billions of parameters. Now how to train it? Because if you sit down and train it on your just one device, it would take days or months or weeks, and you don't want that. You want it to be fast and you want it to be efficient, and that's where the parallel training comes in. So here we can train our deep neural networks across multiple devices, GPUs, and even machines, so we instantly fasten our training process. Okay, now what about the ecosystem of PyTorch? So guys, trust me, it's top notch. For every use case, PyTorch has libraries. Like for audio, it got Torch Audio. For reinforcement learning, we got Stable Baselines, Torch RL. For text, we got Torch Text. For vision, we got Torch Vision. And there are tons of libraries more. And that's why PyTorch is not just another framework, but it's an entire ecosystem, just like Apple, right? And lastly, PyTorch is loved by almost all researchers because it's intuitive, flexible, reliable, and has very minimal or negligible abstraction. Okay, so time for a quick summary. First, tensors are the core unit of PyTorch, and PyTorch is highly optimized for doing tensor based operations. So no tensors, no PyTorch. Next, PyTorch has a dynamic computation graph which makes experimentation and debugging very easy and intuitive. Next, PyTorch got AutoGrad, which automatically computes all the gradients involved in the training of the neural network. Next up, in PyTorch, we can move our tensors into GPU so that we get an instant speed up whenever we are doing tensor based operations. Next up, PyTorch gives us NN module, which provides us highly optimized layers, loss functions, activation functions, which we can use in building our neural networks. Next, PyTorch gives us the Optim module, which provides us all the optimization algorithms using which we can update our neural networks during the training process. Next up, PyTorch provides us some data utilities using which we can handle data absolutely like a pro and train our neural networks efficiently. Next, PyTorch has TorchScript, by which we can use our PyTorch models in other environments rather than just sticking to Python. Next, PyTorch lets us scale our training process across multiple devices or GPUs or even machines so that we make our training process much more faster. And lastly, PyTorch is highly intuitive, very flexible, has very less abstraction, and that is why it is used extensively in research. Alright, now it's time to look at the core modules of PyTorch. Okay, so at the very first we have Torch. So this is the core package which PyTorch provides us, and this is what handles tensors, tensor based operations, device managements, and everything. So you can think of Torch as the engine of our PyTorch. Next up, the NN module. So it provides us pre-built layers, activation functions, loss functions, which are highly optimized and which we use in building our neural networks much more faster and efficiently. Next, we got the Optim module, which provides us optimization algorithms like AdaGrad, SGD, RMS Prop, Adam, which we use in updating the parameters of our neural networks while training. Next up, AutoGrad. So this is the automatic differentiation engine so that in our backpropagation algorithm, we don't have to sit and manually compute all the gradients, which would probably take ages. Next, PyTorch provides us data utilities, which we use in handling our datasets very efficiently. Next up, the CUDA module. So this is what handles the GPU operations and makes computations lightning fast by utilizing GPU whenever we are doing tensor related operations. Next up, the JIT module, which is short for just-in-time compiler, and this is what helps in converting our PyTorch models into TorchScript so that we can use them in other environments rather than just sticking to Python. Next up, the ONN package, which makes our PyTorch models compatible with other frameworks. So the idea is simple. We built our PyTorch model. Now we export this to an ONX format so that we can use it in other frameworks like TensorFlow, Cafe2, etc. So that we are not just limited to PyTorch. Okay, so it's now time for a quick summary. So first we have the torch module, which is the core package that PyTorch provides us, and using it we can handle tensors, tensor related operations and GPU management. Next we got the NN and Optim packages, which makes the process of building neural networks and training them much more faster and efficient. Third, we have AutoGrad, which is an inbuilt differentiation engine in PyTorch, which automatically computes gradient, which we use in our backpropagation algorithms. So again, it makes the process of training neural networks much more faster. Fourth, we have data utilities, which makes the whole process of bringing data, storing data, data manipulation, data batching, pre-processing very simple and efficient. Fifth, we got the CUDA module, using which we utilize GPU whenever we are doing tensor based operations so that we get an instant speed up. And lastly, we got JIT and ONX, using which we can use our PyTorch models in other environments, so that ensures cross-environment compatibility. Alright, now it's time for the showdown. It's PyTorch versus TensorFlow. Let's go. So first up we have the computation graph. So in PyTorch, it's a dynamic computation graph, which means that the graph is built on the fly. So whenever we perform any operation, it gets appended into this graph, and this makes debugging and experimentation very easy and intuitive. Whereas in TensorFlow, the earlier versions had static computation graph, but the latter versions started supporting eager mode, where we have dynamic computation graph. So basically they both have dynamic computation graph. Next, ease of use. So PyTorch is very much like Python, so it is very intuitive and it has almost negligible abstraction, so you literally understand every piece of code that you are writing in PyTorch. Whereas in TensorFlow, we don't have so much of transparency because there is a layer of abstraction, and therefore it requires usage of boilerplates. But ultimately it again got simplified in the latter versions. Next up, AutoGrad. So PyTorch uses AutoGrad, which is an automatic differentiation engine, whereas TensorFlow, for calculating the gradients, they have gradient tape. So both of them are automatic and both of them works great. But the PyTorch one, as I've told, it is a bit more transparent and debug friendly, whereas the TensorFlow one, it again has a bit of abstraction, so you don't understand everything very clearly. Next up, performance. Because PyTorch has very less abstraction, that's why it's used more in research and in model paper implementations. Whereas TensorFlow, it has some boilerplates and has abstraction, so it's not that great for research, but it's used more in the enterprise or in the production pipelines. Next up, model deployment. So PyTorch supports torch script, torch serve, ONX export, whereas TensorFlow supports TensorFlow serving, TF-Lite, TF-JS, TFX pipeline. Next up, the domain focus. So I've already told that PyTorch is favored more in research, whereas TensorFlow, it is favored more in production pipelines or in enterprise use cases. Next up, the ecosystem. So PyTorch has a rich ecosystem of multiple libraries for almost any use case. So it has Torch Vision, Torch Text, Torch Audio, Torch RLs, and many more. Whereas TensorFlow, it has TF Hub, TF Datasets, TFX, and all of them are great. Next, we have the inventor. So we have PyTorch by Meta and our TensorFlow by Google. Next, the GPU support. So both PyTorch and TensorFlow have strong GPU support, but actually TensorFlow wins over here because it has an additional TPU support which is missing in PyTorch. Next, the learning curve. So PyTorch it is very much easier for Python developers to adopt because it is very much Pythonic. So if you know Python, then you'll absolutely gonna love PyTorch. Whereas TensorFlow, it has a bit steeper learning curve because it has abstraction, includes much more boilerplates. Therefore, the coders, they have to stick with it with some time so that they can understand it properly. Next up, both PyTorch and TensorFlow, they have their own high-level API. So PyTorch has Lightning and TensorFlow has Keras. But guys, if you're all just starting out or even have some knowledge of deep learning, I would say just blindly start learning PyTorch, because that is where the actual magic is happening, and trust me guys, you'll never regret. Alright guys, so PyTorch is not just another deep learning framework, but it's an entire ecosystem that Meta has built. So for literally any use case, we have libraries and packages within this ecosystem, and they all work together very efficiently. So I've listed some of them over here, like Torch, Torch Vision, Torch Text, Torch Audio, Torch Data, Torch Metrics, Torch RL, Stable Baselines, Clean RL, PyTorch Geometric, which is used in graph convolutional neural networks. Then we got Lightning, Hugging Face, Fast API, and these are all of them which are included in this ecosystem. And there are much more libraries which I've not shown over here. So that's why PyTorch is an entire ecosystem which makes a deep learning much more faster, much more cleaner, much more efficient, and way much more fun than TensorFlow. So that's PyTorch simplified. In the next lecture, we're gonna dive into tensors, and it will be very practical because we are going to write code in PyTorch for tensors. So take a break and I'll see you in the next one.